Hi everyone, and thank you very much for inviting me to speak to you all today. I'm very excited to talk about one of my favourite topics, which is mine life cycle planning. You know, how we actually think about the mine from inception to closure, and how sustainable operations are no longer a matter of if or when, but it's more a matter of how. And there's, I think, some fantastic things happening around the world in terms of rapidly driving sustainable operations. So I know I often start a lot of my speeches with this particular slide, but I think it's as always, a really important thing for us to reflect on, which is the fact that our job as leaders, you, I, leaders in the industry, leaders of our teams, that our job is not just to prepare ourselves for an accelerating rate of change, but to prepare our teams for that fact as well. And, you know, as all of us will know, we live in a time of accelerating rate of change. So whether that is the technologies that we use at home, how we interact with the world, how we get data, how our peers get data, the interactions that we have, and no more so than during this time of COVID change, where a lot of us are now working remotely and have been doing so for the last 18 months to 2 years, and have made that shift very, very seamlessly. So why do I say that? Well, that is also impacting not only what others think about our industry and the expectations that they have. So, you know, the expectations they have in terms of our level of sustainability, the expectations they have in terms of the technologies that we use within our industry, the expectations we have in terms of the interactions that we have with governments, with communities, the expectations that they have with the value that their natural resources deliver to them. It is also, though, driving this rapid change in the technologies that we can use in order to drive not just improved sustainability in our operations, but radical change in the sustainability of our operations, disruptive changes. And that's not only coming from clean tech industries, which I know the US has been at the forefront of for many, many years, but it's also driving you know, how we think about power, how we can use digital technologies in order to try out different ideas before we even have to think about them in the real world. And this, you know, this is also changing the cost structure. So no longer are some of these technologies out of our reach. And, you know, we've been just looking recently at things like solar systems that have gone from $75 a kilowatt hour around about 10 years ago, now are sitting in most countries that I've looked at recently and spoken to organisations at around about 4 cents, which puts it well, it was significantly cheaper than its diesel alternative, than its LPG alternative, even often when that grid power is going right past your door in terms of a mining operation. But when we then add the risk that we run by continuing to using conventional methods, and especially when we know that those methods are going to have to exist for 5, 10, 20 years when we're establishing our operations, or when we're switching from one trucking fleet to another, or from one, you know, movement style to another, the risk that we run that in 5 or 10 or 20 years that we will no longer be able to attract the investors that we want. And you know, one of the interesting things recently, looking at sustainability investment funds, they're no longer fringe, they're very much mainstream. Last time I checked, there was around about $40 trillion in sustainability style funds and sustainability style investments, which is around about 35% of the world's assets under management. You can currently get somewhere between 5 and 10 basis point improvement on your loans for sustainability approved investments. And similarly, if you're issuing bonds, an improvement in the bond rate for those with sustainability credentials and with sustainability efforts. So, there's a shift happening, and I think there's a lot of risk for those of us that don't move fast enough, that some of the consequences going forward could be quite significant. So what are the sorts of problems we need to solve in order to drive sustainability in our operations? Well, luckily, they are the same problems that demonstrably that we've been trying to solve as an industry for some time. So we have a lot of skills in this. Again, it's around how do we rapidly change the rate at which we are solving these problems. So the 5 that I know I've been speaking about for some time: global ore body intelligence. So if we could understand our ore bodies down to the last gram, down to the last metre, know exactly where our ore bodies are. If we could find ore bodies 10, 20 times faster at half the cost, and, as I said, understand them more completely, that in itself would drive significant sustainability changes within our operations, because there is so much that we could do to set our operations up for success at the beginning. We could avoid some wastage. We would, know exactly how we're going to drive those operations. And I think for me, this is one of the keys to really improving ourselves as an industry, is really spending more effort, more time, understanding those ore bodies and of course, finding ore bodies faster than we do at the moment. Autonomous electric mine, I think that speaks for itself in terms of how that links to sustainability. But again, something that we really need to drive rapidly so that we can have people out of the coalface, working more remotely, working in more office environments, monitoring the equipment, solving more complex problems, training, maintaining equipment rather than necessarily operating equipment. That will require us to train our people up for higher skills, for more complex work. But I think we certainly have that capability within our industry. And of course, when you automate, electrifying our operations, again, is a significant advantage. And, we'll show some of the examples of those sorts of technologies, but, a fully electric mine today is not out of the reach, and especially when you automate, because and I've spoken about this a few times over the years, but as you automate, the size of equipment that you need can come down. The way that we can move material can radically change, and then this puts an electric mine well within our reach. I know there's still some challenges on the processing side, especially around comminution, but again, some fantastic work going on, in the comminution side, in the explosives sides, in the preconditioning side, in order to use other mechanisms to break rock, to take the load off. And then some great work going on in terms of storage and different storage styles, with the attempt to be able to start up especially some of the ball mills, etc., under a renewable energy sourcing. Precision extraction, how do we actually stop moving a lot of the waste? And again, I think this is also key to radically changing the sustainability of our operations. Taking ideally just the metal that we're interested in, so that tends towards in situ leaching, and again really trying to solve and put effort into how do we do that level of extraction, so that operations like the one behind me with large open pits become fewer and fewer. How do we think about underground operations? And we've been doing a lot of work recently with organisations around caving and block caving, and how do we reduce the risk associated with nominating a block cave as one of the options towards our boards, etc. And then symbiotic development is how do we bring a lot of these resources and thinking to our communities to help drive within governments, within communities, those mechanisms for long-term shared prosperity. And of course, disruptive business models. How do we rethink a lot of the ways we go about doing things in mining, especially with the benefit of a number of these technologies that can help us solve some of those most complex problems that we want to think about. I think one of the keys, though, to how we're going to drive sustainable operations, and it is a matter of not, will we drive sustainable operations? When will we drive it? If we drive sustainable operations, but actually now how? How do we drive those sustainable operations? Part of the how is not just to replace one way of the way we've always done it with a slightly electrified way of doing it. So what do I literally mean by that? It's not just a matter of going, well, I've always had a trucking fleet, therefore I'm going to replace my diesel trucks with battery electric trucks, or I'm going to replace my diesel trucks with trucks that run on a trolley assist system. If we just think about it that way, then we still will have some unsolvable problems. What we need to do is actually disrupt ourselves, disrupt our thinking, and go, okay, I need to move material from A to B. What is the most efficient way of moving that material from A to B? If I could improve my planning systems, can I use some conveyance technologies and a much smaller trucking fleet? If I automate, can I even downsize that trucking fleet again so that it puts it in the range of what is available now for battery electric? What can I do to change my need for comminution? Can I blast differently? Can I precondition rock? And there's some really interesting things occurring in terms of especially microwave technologies. Can I think differently around how I extract that material or how I sort that material, so I don't have to move so much waste, I don't have to extract so much waste. So I think it's really about fundamentally disrupting the way we think, rethinking how we go about doing things, and driving substantially different sustainability. And I think the fantastic thing is that technology now is enabling us to think fundamentally differently about our operations. So some of those sorts of fundamental different thinking is using some of the technologies that we have, some of these digital technologies, to be able to predict outcomes so that we can take action ahead of time, we can pre-plan, we can even experience some of these outcomes. So, I'll give you an example of a dam failure simulation that we developed. But in this case, we could use this preemptively. If I put the dam in this particular location, what is the impact going to be if it does fail? So how do I mitigate those impacts? So this is just the terrain that the dam is going to be built on. We have a dam wall. Now we can simulate the failure itself. Here we've just removed the dam wall. And then what is the flow pattern of the tailings that is behind that dam wall? And you can change the viscosity of the tailings, you can change its composition, but essentially you then can have a look at what are the impact that tailings being released has. In this is a very simple model, but we could have put buildings in the way, we could put fields in the way, we could put wild habitats in the way. This particular model shows the speed and the strength of the material as it moves down, blue being the lowest, red, etc., being the highest. And so we can then specifically model the impacts, which then allows us not only to reposition the dam, to reduce the impacts, reposition some of the things that are in the way, create diversion channels, etc. And so why this is, I think, fundamentally important is it allows us to preemptively change any potential outcomes should the worst happen, and really think about, as I said, the sustainability of our operations. We can do in the virtual world before we do it in the real world, therefore reducing the risk, creating greater certainty, and so forth. Mine closure simulations. So how do we start planning for mine closure today, even though mine closure might be 10 or 20 years away? How do we do it from the beginning of the mine so that we think from the very first piece of sod, how are we going to eventually close this operation? What is it going to look like? We can discuss those with governments, with communities. And the great thing I think about these simulations, these movies, four-dimensional, 3D plus time, is everybody can understand them. You don't have to be a technical expert to understand what I just showed you in terms of the tailings dam failures. You don't have to be a technical expert to understand what I'm going to show you in terms of the mine simulations. And so we can then use that for really good discussions with governments, with communities, with board members, etc. But I think, again, part of driving operations that are fundamentally more sustainable is to use these sorts of simulations. So not only are those simulations helping us to think proactively, think ahead of time, but it allows us to try different things, try what if. In that particular example, you saw one of the things that was being simulated was wind turbines. But, again, we could simulate any other form of asset. So the way we think about energy, I think, is another key to driving sustainable operations, and it's radically changing. Before we used to think about energy in terms of grid power, of large power stations often driven, in some cases, in the more remote cases, by diesel, natural gas, diesel driving a number of our mobile equipment. But now we're thinking radically differently around solar, and a number of mining companies I know have put significant solar capability in, have put significant wind capability in. There's more interesting technology appearing in terms of green hydrogen, which I do think is better for fixed plant than the mobile plant. But maybe I'll be corrected in time as technology changes. We're working with some organisations that are harnessing wave power, which is one of the this one here that you can see up in the top corner. There's a lot of research going on into small nuclear reactors, as well as sort of bio fuels, and not only biofuels, but also using waste to generate power. So, we're getting radical changes in energy thinking, and again, we're seeing that translate into mining organisations. But what's helping really then us think about how does the electric mine change our ore bodies, because the economics change. How does it change our mine designs, which it of course does. If you electrify and automate, and you've got an open cut mine, for example, you can most probably take your ramps down from 2.5 times the truck width to 2.1, and possibly even lower than that. The turning circles potentially change in your underground operation as you replace diesel equipment with battery electric equipment. And then I think more importantly, you rethink and potentially change with conveyance technologies. And I think that's where we then get a much more significant change. But again, all of these can be looked at under simulation. You can look at your underground, in this case, mining operations. You can go, well, what does change if I put in different styles of equipment? If I start electrifying my mine, what it changes in terms of my need for ventilation, what changes in terms of my need for power reticulation, how do I set up my battery technologies, how do I set up my charging, if that's what I need, where would I put my conveyors and my conveyance technologies, where would I run my fleets. All of that can be simulated. So here's an example of a very simple simulation to look at different equipment styles. So you can see initially setting up the mine infrastructure, the mine design. You'll see them putting in different types of equipment, watching how that equipment then operates. How does it change particular turning circles, turning capacities, loading rates. This is just running pieces of equipment through that. So it allows us to really model in the virtual world what we want to try out in the real world. And again, de-risking it, because we can see some of the results of those simulations very, very rapidly. We can try all sorts of different things. So the more that we can model, design and simulate in the real world, the real world in the virtual world, the more that we can enable people to experiment and experience those outcomes, the faster we will innovate. And it's really because we will de-risk. We'll de-risk both the experience, we'll de-risk some of the optionality. We can try different things faster. It's much easier to change it in a model than it is in real life. So often what I get asked is, but how real are these simulations? So we build the simulations up from base science and using science from base layers. And I think that is important, that we think about how do we actually much more specifically model what's going to happen. And often that takes some time to get the models right, and to get these simulations right so that they are based on science and science principles. But they, in other industries, in the car manufacturing industry, for example, they don't need to put crash test dummies in a car and smash it against the walls anymore. They're simulations to do that, and how they model the materials, how they model changes in materials, how they model the car, the impact to the human body is so precise that they can run those simulations virtually rather than having to do those in the real world anymore. So what we need to start creating, though, is not just these virtual experiences, these simulations in the virtual world. We need to then start connecting them to real world data to improve those simulations, make them more accurate, as well as change those simulations and predictions as we get more and more data. And this is especially so until we've really solved that problem that we spoke about it earlier in terms of geological understanding and knowing our ore body's down to the last gram, to the last meter, because often things change, as we all know, within our ore body, and then that changes our plans. We also change our plans due to performance requirements of our equipment, etc. So you'll see here in this particular example where we've tried to link some of the virtual experience, some of the simulations with the real world and some of the actuals and the real-time data that has been obtained, to then bring the simulation and the real world together to improve both. So the more that we enable these transformations in the way we go about thinking about things, using technology to transform our industry and drive more and more sustainability within our operations, and help us with the how of that, the more that we do that, the more important that people are to our industry. Because, you know, all of these require changes in the way we go about thinking. Disruption in the way we go about thinking about what we do and how we do it. That level of creativity requires an immense level of collaboration, working together to solve these problems, working together to implement these things into our operations. It requires teamwork, it requires creative thinking, it requires, you know, often teams fundamentally rethinking what they do. And all of that puts people at the centre of our industry, as it always has been. So whilst these are significant technology changes, these are significant changes in the way we think, the way we behave, the way we do things, that it is really still what we always have had in our industry, which is putting people at the centre of our thinking. So disruption is here. And especially in terms of our sustainable operations, many organisations have already embarked down many of these pathways. Speed does matter, because the expectation of our stakeholders is rapidly changing. You know, governments, communities, our workforce, our investors, the bankers that help finance our industry. And so it matters how rapidly we can engage with a number of these technologies, the way we think about these problems, we can engage with our people to ultimately transform our industry. So thank you very much. I'm sure that there are a number of questions that you might have. Very happy to answer those. My email here, you can send me an email, or I would absolutely welcome that you connect me on LinkedIn if you're not already. Send me a text or a message and we can continue the conversation. So thank you very much, and hope you have a fantastic day.